I'm going to explain how to use a pressure enthalpy diagram for water, interactive simulation that allows us to better understand this kind of diagram. The location is given by this link, and if we look at the diagram, we can see that we're plotting log of pressure versus enthalpy, and then we can decide which lines we want to look at. In this case, we're looking at constant temperature lines, the critical lines, so saturated liquid at the lower enthalpies, saturated vapor at the higher enthalpies, and then we're showing the critical isotherm for water. So let's look at the simulation. Well, this is the form you might see it in a textbook, and in black and white, it's pretty complicated. What we try to do in a simulation, one is to make the different lines different colors, and then we remove, let's say we're going to remove the isotherms and the critical isotherm. And now it's a little easier to visualize, for example, the effect of pressure and enthalpy. If we have a liquid and we raise the pressure at constant temperature, we see almost no change in enthalpy until we get to very high pressures. Liquids incompressible pressure has very little effect on enthalpy. If we go to the other extreme, vapor, at low pressures, as we raise the pressure, we see very small changes in enthalpy. So at the very low pressures, close to an ideal gas, and for an ideal gas, the enthalpy does not depend on pressure. Look at a critical isotherm. Well, as we raise the pressure at constant temperature, high pressures, we start seeing a decrease in enthalpy, a rather dramatic dependence on pressure, and it's very complicated as we get to very high pressure. Well, if we look at 100-degree isotherm, there's a big difference in enthalpy between saturated liquid and saturated vapor, of course, due to the heat of vaporization. Well, this diagram allows us, instead of temperature, for example, to look at vapor quality and constant quality lines. Fractions that are vapor are shown here. You can also look at constant entropy lines and see how, as we change, for example, pressure at constant enthalpy, what happens to the entropy. And of course, as we increase a constant enthalpy, as we're increasing the pressure, we're changing the temperature also. So a constant entropy line, pressure and temperature are compensating each other. In this region, the entropy stays constant. Can also look at constant density lines. And of course, as we change, for example, at low density here, as we change the enthalpy, we're changing pressure and we're changing temperature. And then at the higher conditions, things can get more complicated on how density depends on pressure and temperature. Well, we can also display grid lines if we want to be able to more accurately read a value. But the big advantage of this diagram is we can pick which of the constant value lines we display to make it a little easier to understand a pressure enthalpy diagram.